we are happy to enter chapter 3 of this class. Chapter 3 is fun. You are going to learn how to use, you can draw graphical solutions. So, like, could you read this?
Illustrate the graphical solution process.
So in the future, if you know your English is not good enough, so before the class, you should at least read the English. If you don't know how to pronounce it, check how to pronounce before the lecture. Because I'm going to ask you to read a lot. So if you know that, I'm going to ask you to read. You can get prepared. Okay? Be a very good student. Okay? So you know what's going to happen. So now I tell you, read English before the class, that you can read it, that you can check the dictionary. Not only the pronunciation, but also the meaning. Okay? Your biggest problem now, English. Okay? Kaiser, could you read this?
Illustrate the graphical solution process and introduce several concepts related to optimum design problems.
The set. If you we are going to use graphical method by pencil and paper to draw your solution. Yeah, because after this chapter, we are going to use computer. But for this chapter, graphical method prepare you to understand the application concept better. Okay, so remember we have 5 steps. Step 1, problem description. Step 2, get information. Step 3, design variable. Step 4, objective function. Step 5, constraints. So these 5 steps we're going to follow in this class. Kaiser, what are the 5 steps?
1. Design constraints.
What are the 5 steps?
One is the question, object description, which way variable.
See, 1 is the problem statement. 2 is the get information. Okay, it's here. So, Hugh, could you read the first?
A company manufactures 2 machines A and B.
Okay, second.
Using available resources. Either 20 A or 30 B can be manufactured daily.
See, you even pronounce wrong. 14. 14. So this company can make A machine 28 per day and 14 B machines per day. What's the third one?
The sales department can sell up to 14A machine or 24B machine.
Okay, so in a company we have engineer to make the machines. We have sales to sell the machines. For the sales, they can sell 14 machines, B machines, 14 A machines daily, per day. I mean, this one.
The shipping facility can handle no more than 16 machines per day.
So I mean, your English is not good at all. So before the class, read it before the class and check the pronunciation. This way, improve your English. Maybe your interview will be your interviewers will ask you questions by English. Say, introduce yourself using English. Then, if you can speak English fluently, maybe Ahern cannot get a job, but you can get it. English, English, English. So in a company, we have engineer to make the machine. We have sales to sell the machine, but we have truck guys, drivers to drive the machines, to ship the machines. So each day they can only handle 16 machines at most. See, constraint, design variable. So this is problem description, but from this description, you should be able to tell design variables, constraints. Like,
The company makes a profit of 400 on A machine and 600 on P machine.
okay, now the accounting. In a company, we have CEO, we have manufacturing department, we have sales department, we have shipping department, we have accounting department. So the accounting department, okay, for A machine, they can make a profit $400. For B machine, they can make a profit $600. Okay, money making. I have this one.
How many A and B machines should the company manufacture every day to maximize its profit?
So Ahern English is better than you. So he will get a job. Okay, so now it asks A and B, how many we can make each day to maximize our profit. So see, you see maximize. This is the keyword. This is the goal, the objective function. So from problem description, you know your objective function is maximize profit. Your design variable A and B, all these are the constraints. So if you can formulate a problem, the solution is already there. But if you cannot formulate a problem, there's no way you can get your solution. So how good you can formulate your problem, then how good your solution will be. This is the optimization problem. Okay, any question? Do you have any question? Okay, now how to formulate it. Before we do that, step 2 is get information. We collect the data information. But already, almost everything is defined already. Design variables, machine A, machine B, the number, X1, X2, manufactured each day. Then, objective function, the profit for A machine, each one we can make a profit $400. For B machine, each one we can make $600. So this is the money we can make. We want to maximize this amount. Okay, then shipping and handling constraint. Remember, shipping, the truck, the driver, each day he can ship out 16 at most. So let's say this number. Then engineering, manufacturing, per day, they can make either 28. If X1 is 28, then they cannot make any. So this is X2, so this should be 0. Or this one, if the boss tell you, okay, today let's make B machine only. Then the engineers work very hard. The whole day they can make at most 14 B machine. So if x1 is 0, x2 14. So this equation is the manufacturing department. This one plus this one should be less than 1. Because for each day, at most 28 A machine, at most 14 B machine. So, Agan, do you understand this one? Okay, then the sales. Okay, the sales go around the sale machine. But each day, either they can sell 14 A or sell 24 B or sell 2 and say 20. So this amount should be less than 1. This is another constraint. But finally, S1 and S2, they cannot be negative. They should be positive or 0. Okay, we have constraint. Now we need to make it formal formulation. But we'll do that later. Now we don't need to get very formal, say all the inequality constraints less than or equal 0, all the equality constraint. So we don't need to go that far for this problem, for graphical problem. So for graphical solution procedures, we need to select our coordinate, then draw all the constraints and find out the space where we can design our problem. And then plot our objective function, see where we can get the maximum value. So, but we have the detailed step procedure to do that. Again, could you read step 1?
System setup.
See, maybe you should also read before the class to practice your English.
Okay.
So coordinates, because you want to draw something, you need to select the coordinate, design variable A and B. Sorry, your name, SFK, KFK, 冠成, step 2.
Equality concerning from the plot.
Okay, those constraints inequality, less than equal. Okay, draw those boundaries. And your name, please. 冠成, 翔宇. Step 3.
Indication of the feasible region for an equality.
Feasible means the area we can use. They are candidates for the solution. So feasible means usable. Feasible. 翔宇, feasible.
Feasible.
Okay, your name please. 生源. Okay, step 4. Oh, sorry, step 5. Oh, sorry, step 4.
Indication of the feasible region.
Okay. Because this means identify the feasible region for each inequality, but we have many inequalities. So you need to combine them together to find the feasible region. Your name, please. 燕如. Step 5.
Plotting of objective function contours.
Okay, yeah, now it's to plot the objective function. Objective function equal 1000, objective function equal 2000. Let's see if they intersect or in a feasible region. Your name, please. 俊宏.
Yeah.
Step 6.
Identification of the optimized solution.
Okay, the final ultimate solution. Then let me show you how to do this problem. Okay, first we plot the coordinate x1 and x2. x1 is machine A, x2 is machine B. Then we plot those in equality constraints. For inequality G1, we plot the line. Then remember G1 is this. So we have, if we plot x1 plus x2 equals 16, is a line. But remember, s1 less than, if you see x1 less than means it should be the left-hand side of this constraint. See, this one. So 16, and 16, so this is G1. Remember, x1 is less than, so the region is the left of this line. So here is the feasible region for G1. So the shadow means not feasible, and this one means feasible area for G1. Then you can follow this G2, G3, G4, G5. So G1 here, G3 here, G2 here, and then G4 here, G5 here, G4 here, G5 here. So the feasible region is here. So this is a feasible region. Do you understand? Now the next one is to plot the objective function. The objective function is this one. So we have 400 x1 plus 600 x2 equals some value. So we can select some value to plot the contours. So we just try. So we can plot it. If p equal to 2400, plot this one. You plot this one, and you plot this one. Eventually, this value here, p equal to 8800. So if you increase p 2400, then increase. If you increase this one, it's not in the feasible region. It is only feasible region is here. So if you increase p, it's going to get out this region. So yeah, we find out the maximum value is 8,800. So we solve the problem. Kaida, do you understand? Junhong,
Yo.
do you understand?
Yeah.
Very good. Then, so the value here, x1 equal to 4. So here. So they use x2. Then this is x1. So x1 equal 12. So I made a mistake. So this one should be 12, and x2 should be 4. So I made this should be 12. This one should be 4. Okay.
Is a point D.
You mean point A
Is
or
a
C?
point D. You point
D.
is
Oh,
point.
okay. We can. Oh, this one is a solution. This one also. So we can increase. So this one we can, because this one is, because feasible region is here. So here we hit this point, but we can still increase p till we hit this point. So okay, D is the correct solution. D x1 equal to 4 and x2 equal to 12. Sorry, but okay. Right. So this is the graphical method. Then everyone, please practice this problem. Yeah, everyone, please. It's better you have a ruler to help you to draw more precisely. You can go back to get a ruler. 旗帜.
Now comes the exciting part. We are going to use MATLAB to plot this figure. So the file is figure 3_6.a. Kaiser underscore point. Okay, let's go to figure 3.6 here. So we can run this one. Open with Notepad, and let me increase the size of this. Okay, so here, clear all variables and close all functions. In case we want to start with totally clean, then so this command we create mesh grid like XY coordinates for X1 and X2. So for X1, from -1 to 25, increment 0.5. For X2, -1 to 25, increment 0.5. So we create XY coordinates. Then we have objective function, G1, G2, G3, G4, G5. Remember, minus sign here. Because X1 greater or equal 0, the standard formulation is all less than. So that's why we have minus sign here. Okay? Then figure 1. So yeah, X is auto. You will, according to your XY value, to create the axis for you. Axis auto. Then X label, X1, Y label, X2, title. And hold on means you can plot one contour, then plot another one, then plot another one. Hold on means they will plot in the same figure. So this is hold on command. Then CB1, the contour value 0. This is a vector. The first element is 0. The second element is 0.5. Because we want to have two contour values. You will know why we define this one. Then we plot two specified contours of G1. The reason is 0 is the boundary. and we want to have the less than 0. So if you plug a value at 0.5, you know the second line is the unfeasible region. You know, it's too much to plug all this hash line. So just use one line to represent the unfeasible region. So this is the reason we have 0.5, because we want to plug this way. I can show you the reason why. See, in this figure, we plug this first one is 0, the second one is 0.5. So we know this region is a feasible region. That's the reason. Okay, so you know why we define these two contours. Then contour, like contour S1, S2, and G1. So S1, S2 are the coordinates. Then G1 is this one, G1. And CB1, remember we defined CB1 here, 0 and 0.5, two contours. And black color, black, K means black. So if we go to this figure, see, black is G1. So the first one is 0, the second one is 0.5. Yeah, not clear. 0 here and 0.5. You just mark, because it's too crowded here. So yeah, you need to search for it. That means this region is feasible, and this one is not feasible. This is the reason we have two contours. 俊宏，有了解吗？俊宏不是他吗？
对啊。
好 ，OK。Then we just keep going. See, we have contour 1. This one. Then for the second contour, we use CB2. Contour value 0 and contour 0.03. Somehow you need to adjust, play it. If you use 0.5, it should be too large. So that's the reason we use 0.03. For G2, we use CB2. Blue. For G3, we use CB2, the same. For G4, we use CB3. This one is CB3. And we just, when x1 equal to 1, x2 equal to 23, we plug a text G3. See, 1, 2, 3, G3. We can go back to the figure. When x1 equal to 1, x2 equal to 23, we plug this text G3 here to mark this is G3. So yeah, you play with it. Then contour G4 CB3, yellow, contour G5 CB3, we use CB3 vector. Green, then we just create feasible region. Then the objective function, we take these several values, four contours. So for F, we use the 4 contour values, FV 1, 2, 3, 4. Color, magnesis. Line type, this is dashed line. So we have 4 contour lines, 4 contours for the objective function. If you look at this one, see, magnesis, the color, this is magnesis. Then dashed, 1, 2, 3, 4. We have 4 contours. Then this is the contour value. Yeah, so use MATLAB, you can plot this one and plot the second one. Oh, you know, okay, we need to plot more. Then you can play with it. You use your hand, it takes a lot of time. But if you use MATLAB, easier for you to adjust the values. Okay? So now I want you to download. You can go to iLearning and download this file and run this one. So we will come back here 2:30 p.m. So I hope when you go back to your office, you can run this one and understand the meaning of each line. So 2:30, when you come back, I will ask you some comments. I will find someone to answer me the questions. So if you have problem, you can ask either, I think, Lai, Hugh, I don't know about Taiwanese, but maybe you can ask the TA for help. They know pretty much. So do you have MATLAB? Have you ever used MATLAB? This class you can learn MATLAB, okay? It'll be good for you maybe someday. And you can install MATLAB. So our school has the MATLAB software. You can download from school website and install the software. And probably let's come back here around 2:40, okay? And you have time to install. If you have any problem, come to exit, okay?
Yeah.
All right, I'll see you 2:40.